In question 1, we have a speed time graph, something like this, for a vehicle entering an escape lane. In 1.1, we're to find the force decelerating the vehicle 2 seconds after entering the lane. Well, 2 seconds is about here, so what we need to do is draw a tangent to the curve at this point, find the gradient of that tangent, and I found that to be along here to be around about 15.0 and here to be 5.6 seconds, and so the acceleration is change in velocity over change in time, which is 15 over 5.6. You'd get slightly different figures probably, which comes out at 2.7 meters per second squared. We can then use F equals ma. We're given the mass at 1.8 times 10 to the 4 kilograms. Multiplied by our acceleration we've just found at 2.7 gives a force of 48600 newtons, or 4.9 times 10 to the 4 newtons, to two significant figures. In 1.2, we're asked if an 85 meter escape lane would be long enough. Well, to find the distance travelled, it is the area under a speed time graph, and for this I counted the squares. I got 22 little squares. Each of these is 2.5 meters per second times 1 second, and this gave me 55 meters. Therefore 85 meters is long enough. In question 1.3, we're asked to discuss the energy transfers taking place. Well, the kinetic energy of the vehicle is transferred initially to kinetic energy of the moving gravel, then to thermal energy of the gravel, and also the gravitational potential energy where the gravel has been piled up. In 1.4, we're to discuss whether a 25-degree, 85 meter long ramp would be sufficient. Well, in this case, kinetic energy is becoming gravitational potential energy. So mv squared over 2 is becoming mgh. Can cancel out the masses, and we want to know the height, which is going to then be v squared over 2g. V is 17 meters per second, so we square this over 2 times 9.81, meaning we need to get the vehicle to a height of 14.8 meters. The ramp is something like this. This is 25 degrees. This needs to be 14.8 meters as a minimum, and we know then that sine 25 is opposite, which is 14.8 over hypotenuse, which is the length, giving us a length of 14.8 over sine 25, which comes out at 35 meters. Therefore 85 meters is long enough. In 1.5, we're to discuss the relative merits of the gravel and the ramp. Well, a ramp would give a uniform deceleration, whereas the gravel may give a very large deceleration at first, and it could lead to the vehicle being bumpy and difficult to control. If the vehicle has no brakes, the gravel would at least hold the vehicle still once stopped, whereas it could end up rolling back down the ramp.